Just one night, all we got. Just one night, all we got. Just one night, all we got. Just
that only I will watch on the screen in front of me. There we go.
Just one night, all we got. Just one night, all we got. Just one night, all we got. Just one night, all we got.
A little party never killed nobody, so we gon' dance until we drop. A little party never killed nobody. Right here, right now is all we get. Skidding ba-da-ba. A little party never killed nobody, so we gon' dance until we drop. Let's go on. A little party never killed nobody. Right here, right now is all we got. Oh, a little party never killed nobody, so we gon' dance until we drop. A little party never killed nobody.
Thanks. All right, this is CS50, and this is Lecture 8, and that was a look at the so-called CS50 Hackathon, this annual tradition with which we nearly end the semester that will start around 7 p.m. here in Cambridge, will then end around 7 a.m. the next day in Cambridge, and punctuating the evening will be quite a bit of work on final projects, which is the overarching goal of the evening, to give students both an academic and a very social and collaborative environment in which to tackle their final achievements in the course. But also, as you gleaned there, will be a bit of distraction, a bit of food from Felipe's, typically around 9 p.m., a little bit of Domino's pizza around 1 a.m., and for those still standing, as in the Muppet there, we'll treat you to breakfast at IHOP if you still have the energy. Thereafter will be the so-called CS50 Fair, the climax of everything that you've done in CS50, and more on that in the weeks to come. So without further ado, where have we been these past several weeks? Well, recall that over the past couple of weeks, we've been introducing web programming. And most recently, did we try to tie together a lot of the topics from the past few weeks. HTML and CSS and JavaScript, and then Python, and then another framework, another piece of software called Flask that just made it easier and more possible to build web-based applications. And the simplest example of that last week, recall, looked a little something like this. And this past week, with the problems on similarities and survey, have you been building your own web-based applications, but they haven't quite had all of the pieces that you might want to assemble into a web-based app. And so today, we'll fill in those final blanks. But recall that we've been trying to frame these applications not as one-offs or just tools that you built, but as part of a common paradigm or a methodology. And indeed, when you're learning computer science and software engineering, you start to notice patterns in the software and the code that you're writing, and humans tend to adopt these patterns because they save you time, and then everyone can kind of speak the same language, so to speak. So MVC was the acronym we introduced last week, Model View Controller, and that just speaks to this paradigm whereby you organize certain type of code in one file, certain types of other code in another file. So your Python code goes in application.py, your HTML goes in your HTML files, your CSS in your CSS files, and so forth. But what we didn't have last week was this thing here, really. Model generally refers to your data, and while survey, your most recent problem, did have data, a CSV file that's arguably a model, CSV is not terribly expressive. You can pretty much just write rows to a text file, not unlike a spreadsheet, but you can't really query it. You can't easily insert or delete. You pretty much would have to reconstruct the whole file. And indeed, that's exactly what I did back in the day. The very first web-based application I wrote back in sophomore or junior year was the Freshman Intramural website, and all I had available to me, both technologically and conceptually, were CSV files. I had no idea what databases were, didn't realize how much easier they could make my life, so I stored all of the data behind these links here just in very simple text files. But today we'll give you so much more power, and especially if you're coming into the class with an interest in applying CS to other fields, in medicine or the arts, or any world in which there's data, particularly in STEM and data data science and the like, realize that SQL has really become this incredibly powerful language with which to solve problems in those and so many domains. And ultimately, what you're build this coming week, your very last CS50 problem set, you have now peaked just about, will be CS50 Finance, a web-based application via which you can buy or buy and sell stocks. And so what you're going to do this coming week is write code that implements a web application that resembles this, whereby your users and yourself will be able to register for an account, log into that account. You'll be given for free, thanks to us, 10,000 virtual dollars. And then you can go ahead and buy and sell stocks via their symbol using this application. So for instance, if I go ahead and register myself here, let's say username Malin, password 12345. Shouldn't have said that. Go ahead and register here. You'll see that by default, I get this free $10,000 in virtual cash. You know what? I'm going to go ahead and buy myself a share of maybe Netflix, whose symbol is NFLX. I'm going to go ahead and try to buy one share. Voila. And now you'll see that not only do I have less cash left, about $9,600, I now own a share of stock. And if we reload this throughout the lecture, frankly, the price might go a little up or a little down, because this web application you'll build will also talk to an API, an application programming interface, so some third-party website that provides you with stock data. So you ask it for the current price of a stock, it gives you an answer in JSON format, if you recall our short discussion of that, and you'll integrate it ultimately into this interface. So this will be the culmination of so many of the ideas and the building blocks with which you've experimented, but we need a few final pieces today. So first and foremost, when I registered for this site, I created an account, and indeed I can go ahead and log out now. And if I go ahead and log back in, if no one's stolen my password yet, I can see my account and only my account. But we haven't yet seen any mechanism in code whereby you can implement this notion of logging in. Right? What is the underlying logic via which a website knows that you are logged in or you're not logged in? Right? Clearly, when I went to this website just a moment ago, it prompted me to log in, because I was not, because I had logged out. But how did it know that? And now that I am logged in, how does it know that I can click on quote to get just a stock quote, or buy just to buy a stock, or sell? Why does it not prompt me every time I click a link to log back in with my username or password? What do you think?
Cookies, little files that saves the data inside your browser's cache to let it know what's going on.
Yeah, cookies, little files that get saved by websites on your computer. Now, odds are most everyone here has probably heard in some form cookies bad. Maybe bad, privacy invading, yes. OK, so true. But most of the web would not work without them. So someone else, what do you understand a cookie to be? What is a cookie?
Basically saves your information, so you don't have to put it every time.
Yeah, it saves your information somehow, so you don't have to put it in every time. So in simplest form, it's exactly a combination of those answers, whereby when I log into a website, you could imagine that website just remembering my username and my password by just saving them in a little file on my Mac or PC, so that the next time I visit a web page, it just automatically sends them for me so that the human doesn't have to type them again and again. Now, let's find fault with that. Feels like that would work, but what's the downside of that naive implementation? What do you think instinctively? The data's just out there, right? You know, I have people in the office or at home or in a library that I might not want to just be able to walk up to that computer and just see this little text file planted on my computer, because then they could log into my account by just digging around. So it feels a little invasive. Indeed, that's one of the threats of cookies. So it turns out cookies or websites tend not to do that, at least if they're implemented well. They instead just plant a really big random number on your hard drive or in your computer's RAM or memory. So 1, 2, 3, 4, 5, 6, 7, like some really big number, maybe with letters and numbers, maybe even some punctuation that uniquely identifies me. And thereafter, anytime I click a link on that same website after logging in, my browser, thanks to HTTP, the language that browsers and servers speak that we discussed a few weeks back, just magically sends that same big random number to the server again and again. And so long as the server remembers that that big random number corresponds to username Malin, it can figure out whose account to show. And why is it a big random number? Why is it not just my password or my username? Why am I proposing that it'd be a big random number?
Because people can guess it by just using like random thing generators.
Exactly. In computer science, randomness is this incredibly powerful ingredient. If you pick a big enough word or a big enough string or sentence, the probability that some random adversary or bad person on the internet is going to be able to guess or try to guess that value is just so low, it's just not realistically ever going to happen in your lifetime statistically. And so randomness gives us that capability. And so you can think about this metaphorically in the real world as being like a hand stamp. If you've ever gone to like an amusement park or a bar or a club where you have to show your ID or you have to pay for a ticket on the way in, sometimes they'll stamp you with either visible or invisible ink. And that's largely for efficiency so that thereafter, when you're in the amusement park, you can kind of come and go and you don't have to repay or reprocess. If you're in the bar or the club, you don't have to keep showing your ID. They can check once and then more efficiently let you come and go as you please because you're just presenting your hand or this virtual hand stamp to the bouncer or to the gatekeeper at those places. So cookies are exactly like that. Unbeknownst to us all this time, anytime you visit a website into which you've logged in, your browser is secretly but usefully presenting a hand stamp to that server to remind it who you are, or rather, not really who you are, but of that big random number so that if the server remembers who that number belongs to, it can figure out whose account to then show. So put more concretely, if I actually pull up some of the HTTP examples that we looked at in the past, let's consider this in context. So almost everyone here has probably used Gmail at some point, and you log in generally via a page like this, so it might be infrequent because you're not often prompted to log into Gmail because of, surprise, surprise, cookies from Google being on your computer, but let's see where those come from. So when you request Google or gmail.com, you might send in a virtual envelope, so to speak, from your Mac or PC to the server, a message like this. Families who've not seen this before, this is what your browser is actually sending to a server in order to request a home page of gmail.com. Now I'm going to simplify this a little bit because there's a bunch of redirects, HTTP 302s and 301s involved that aren't that interesting today. So let's just assume that Gmail responds immediately. Typically, Gmail would respond with this, saying 200 OK, here's the login page, and here's a web page in text/HTML format. But once you've logged in, what Gmail actually does is it also sends this. Recall that we called these things HTTP headers. Key value pairs separated by colons that are sort of semi-secretly sent from browser to server and from server to browser. Now we, more sophisticated developer types, can see this stuff, right? You can open up Chrome's network tab and start poking around in it. It's not secret per se, it's just most people don't know it's there. And what Google and other companies are doing is they literally send a header called set-cookie, the value of which is that big random value that the server has decided for you. Your browser, assuming it speaks HTTP properly, should then save that value in RAM, your computer's memory, or on your hard drive. And then every other click you make on gmail.com should send not just headers like this, but it should send kind of the opposite header, just cookie. Not set cookie, but cookie, which is the presentation of that hand stamp. And so every time you click a page on Gmail or Facebook or almost any website into which you've logged in, those cookies have been planted on your computer. Now, recently, in both Europe and in the US, have laws been passed that are increasingly putting pressure on companies that operate internationally to present you with cookie-based information, right? You get these little pop-ups increasingly, and you've been getting them for years in Europe saying, can we plant cookies on your computer? So given all of this, what might happen if you say, no cookies on my computer? You're going to have to keep logging in, right? If you take away this fundamental HTTP feature, much of the web breaks or the user experience deteriorates significantly. Now, the flip side is cookies can be used not only for good, so to speak, but also for evil. It turns out that there's a lot of ads on the internet, of course, and that's what drives a lot of the revenue that makes it all possible. Those ads typically come from image tags in your HTML or script tags or some of the HTML tags we have seen in the class, but they go to third-party servers, somewhereelse.com. And the problem arises with cookies when those third parties are allowed to plant cookies on your computer, because if you go to Google and you go to Facebook and you go to Twitter, bunches of websites, suppose they all have some middleman advertising service advertising on each of these websites. That middleman, so to speak, because they have their ads and therefore their HTTP headers on this site and this site and this site, there are big third parties out there, lots of them advertising networks, that know everywhere little old you is going because they see your cookie appearing from multiple different other sites. And so here's where cookies become not a computer science engineering feat, but really a threat to one's privacy because they can be used so easily for tracking. And frankly, AT&T and Verizon, as an aside, got into trouble, though even not enough people know this, some years back when they started injecting forcibly additional HTTP headers, similar in spirit to this, to all of people's cell phone traffic. So not things you could even opt out of initially, because this was a way, too, for advertisers and for themselves to be able to track users. So these HTTP headers on which cookies are based are very powerful, but also very invasive. And we're only now starting to see societally and politically pushback on this very simple mechanism that hopefully we as CS types just understand the mechanics of, and therefore now the implications. So let's see this in context, for instance. Let me go ahead and open up a relatively small example in CS50 IDE. For those unfamiliar, CS50 IDE is a web-based application via which you can write programs in the cloud just using any browser on a Mac or PC. I'm going to go ahead and into my account here, and I'm going to go into Store, and I'm going to go into the templates directory and show that this example here has a few files. This will look familiar to students in the room. Application.py is the web-based application, and then we have some template files, so to speak. In my terminal window here, I'm going to go ahead and with just my keyboard go into this directory called Store in source 8, which is available online. And I'm going to go ahead and do flask run, which for those unfamiliar is the command via which you can start a web server and start running a web-based application. So now that I have that, I'm going to go ahead and visit exactly this URL here. And we'll see a relatively simple and super ugly web store. Let me go ahead and zoom in a bit. And this web store allows me to buy 3 things: foos, bars, and bazes, whatever those are. And this is a very simple e-commerce-like site where I just have to type the quantity of foos, bars, and bazes that I want. And then I can go ahead and buy them. So I'm going to go ahead and say, give me 1 foo. How about 0 bars and 2 bazes? And I'm going to go ahead and click Purchase. And now you'll see my shopping cart. But if I continue shopping, you'll see that it resets, just like if you keep browsing Amazon or whatever other website. But if you want to check your shopping cart again, notice it's remembered what I'm looking for. And in fact, you know what? I'm going to go ahead and close the window. Oops, I actually lost the website. But you know what? If I go back to that URL and reopen, I see the storefront. But if I view my shopping cart, it has remembered my state. So notice the power now of cookies is not just to remember with a hand stamp who you are, but now you can remember anything about that user that you want, right? A shopping cart on Amazon or any website is like the best example of this, because it would be horrible, horrible, horrible for a user experience or UX if every time you clicked a darn link, you lost the contents of your shopping cart because the website forgot who you are. So this is a compelling feature to remember, and it's cookies that implement this feature too, because more generally what's going on with cookies is this. When you set a cookie using the set cookie header that looked like this, there is a key value pair to the right that we might call session, and that has the value. Value is the hand stamp. Session is just a term of art that refers to this abstraction that you can think of really as a shopping cart, but it doesn't have to have anything to do with actual shopping or e-commerce. It's just a container in which you can store stuff. So this is telling the website that my session value, my hand stamp, is 1, 2, 3, 4, 5, and big, really random number. The website can then say, you know what? I'm going to store a container for you. Let's call it a Python dictionary or dict for you, inside of which I can put anything I want. And so in fact, when you go to a shopping cart like this, what is the server actually doing? Well, upon seeing your hand stamp and realizing, oh, you are user 1, 2, 3, 4, 5, 6, 7. Oh, that's user named Malin. Let me go ahead and grab the dictionary, the Python dict, from memory, or even from a CSV file if you want, and show you the contents of your shopping cart. Meanwhile, if someone else, Brian, visits this same exact website and logs in with his account, he's going to present a different hand stamp, presumably. And so the website can look for a different dictionary and show Brian the different contents of his shopping cart. And the same for everyone in this room. So this simple mechanism, I mean, consider the power. This is just a stupid text value, key, value. And from all of that, does all of the web's capabilities now come? And we won't look in too much detail into the code here, but let me show one snippet of it. If I go into application.py, the magic that makes this possible in Flask is just to import this additional feature. You'll recall from the past couple of problems you've worked on, you import from Flask a few things: render template, redirect, request. Well, if you add session to that list, which is the code abstraction of this hand stamp idea, what you can now do is this. Let me scroll down to the juicy part here, and notice that you can do lines of code now, and for the next CS50 finance problem, lines of code like this. Session is just a Python dictionary, or dict. You can index into it using any word, foo or bar or baz, just like you could with dictionaries more generally. And you can store in it anything you want. In my case, I want to store a number, 0 foos or 1 foo or 2 foos or whatever. So I can simply convert to an int the user's requests forms item, whatever that is. And let me wave my hand at some of the code above because it just kind of sets the whole thing up. But the new line of code, the new feature that now will empower us to build something like a stock trading website is quite simply this line here. Because what you can also do to remember that a user is logged in, just go ahead and store in this so-called session a value of like true. And if the value true is there, you can infer that the human is logged in. And if there's no such value in the dictionary, they are not logged in. And so we'll hold your hand a bit more in the next problem set with this introduction of CS50 Finance. And we'll write some of the code that handles the login so you can see by example how to do this. But it'll be up to you thereafter to start remembering what stocks a user actually has using sessions to retain the fact that they've logged in already. All right, so that was a lot all at once. But any questions on cookies and the feature they provide, these things called sessions? Anything at all? Yeah? Is the session saved on the user side or the server? Really good question. And the answer can be it depends. You could store it on the user's client, on their browser. And as the gentleman up here proposed earlier, you could, or over here proposed, you could theoretically store like literally their username and password. Maybe I proposed that earlier on their computer. And that's bad for the reasons that we surmised earlier. But you could also store the contents of their shopping cart, foos, bars, and bazes. That's not quite as invasive as storing their password. But if you're buying things you don't really want people knowing, that is then invasive. So maybe we can do better. And better is often stored on the server. So a well-designed website will typically store only this big random value, the hand stamp on the Mac or PC, and then all of the interesting and maybe sensitive stuff is stored in a database or a CSV file or just the server's RAM or memory, like in a global variable. Good question. Other questions? Other questions? No? All right. So that's one problem solved. We know now we can implement login forms, and we know that we can remember that people are logged in. So let's just stipulate that is now possible. But over the past couple of weeks, it's not been incredibly powerful to only have access to things like CSV files, comma, separated values, which create the illusion of like Excel and Google spreadsheets and Apple numbers like columns and rows. Why? Well, it's pretty much linear search for everything, right? A CSV file is just rows and rows and rows and rows of data. And if you want to search for anything in that file, like you might have wanted to for your survey implementation, how do you find it? Well, you open the file with open. You maybe use a for loop and iterate over every single line looking for some value, and then you close the file. That is big O of n. In the worst case, the thing you care about is at the very end, and that's not terribly efficient. Now, you can append to files pretty efficiently. Recall that when we open files with quote unquote A for append mode, we did this with a brief example instead of W for write, you can get the operating system's help and add rows to the file at the very bottom, which is more efficient. But you can't insert things in the middle very efficiently. You can't delete things very easily. You would have to literally, for those kinds of scenarios, open the file, read the whole darn thing, then write out parts of it or add to it as you're writing out. And so humans years ago realized, well, this is stupid. All of us humans in the world are constantly writing code to open files, change files, save files. Why don't a few of us do an even better job of implementing that feature and then share it with the world? And thus were born, effectively, databases. And these days, there's so many different types of databases. You might be familiar with tools, commercial software like Oracle or SQL Server or Microsoft Access. And in the open source world, there's Postgres and MySQL and SQLite and others. And many of them, as even those names imply, use a special language called SQL, Structured Query Language, which is the very last language we'll introduce you to in CS50, unless you go off on your own with final projects to pick up something more. But with SQL, you have the ability to select data from a database, to insert it, to delete it, to update it, all of the things that you could absolutely do with Python and CSVs. It would just be so darn tedious to write those lines of code yourself. So what's the right mental model? Here is, I claim, essentially a database. Like most everyone in this room has probably used Google spreadsheets, and if you've not, probably Excel or maybe Apple numbers. So these are spreadsheets, and they're essentially what you could call a relational database. Relational implying that there's relationships among the various data in the rows and the columns decided by you or whoever made it. And this is a spreadsheet, of course, and it has rows where your actual data goes, and columns. And what's noteworthy about the columns? it's just conventional to do what with the columns, especially in that first row? Yeah, put some header values, right? You could certainly put them in the left. It's just humans prefer, it seems, to read top to bottom instead of left to all the way to the right. So we just adopted a convention years ago that your columns represent different types of data and the rows represent different values for those fields or for those columns, so to speak. So if you wanted to store like a spreadsheet of values for a bunch of students in a class or in a university, one column might be ID number, like their Harvard ID or their Yale ID. Another column might be their name, their email address, phone number, age, and so forth. And you could just lay that all out. You can make it pretty and boldface the top and organize things and sort it. But at some point, this isn't quite the right tool. And in fact, I ran into this in grad school years ago where I was analyzing large sets of data. And it was just convenient to double click on a CSV file, open it in Excel, and just manipulate it and answer the data questions that I had. But back in the day, Excel actually had a limit of 65,536 rows. Sounds like a lot. And that's 2 to the 16th power, if you caught the reference there. And so humans at Microsoft decided years ago, that's enough. And frankly, it kind of was, because even in the thousands of rows, like my Mac just became unusable because there was just too much memory being used. So it was just an impractical limit anyway. But at some point, you might want to store 65,537 rows of data, or hundreds of thousands of rows, or millions of rows, or even more. I mean, there's so many websites, Google and Facebook and others, that surely do this already. You can't just use a program on your Mac or PC anymore. You need to use fancier software. But that fancier software often still works the same way. You have one main file called a spreadsheet in our human world, but in the server world, you might call it a database instead. And whereas in our human world, we might have things called sheets or individual spreadsheets within the bigger file, in a database, you're going to have things called tables. But they're the exact same thing with rows and columns. And so when we want to actually store data, we can actually store it in exactly those ways. So let me go ahead and do this. Let me go ahead and open up Google Spreadsheets just as representative of a database. And let me go ahead and create a new file here. So new spreadsheet. And just so that we can represent things like students, I'm going to call this spreadsheet students. And over here, I'm going to put their ID number and their name. And what are some other fields I rattled off that come to mind? Email. Say again? Dorm, good. Sport, OK, so sports they want to do. Sure, that's fine. A little longer. What else? Graduation year, age. OK, good. So graduation year, age, concentration. OK, and we could probably keep going, and it just gets wider and wider. And these are my columns, if you will, or the fields in the database. And you know, frankly, I could name this if I really want to be tidy here, and I could call this students. And you know what? Maybe I should call this not students, but university, because I might want to have another tab here that will preemptively name to, say, faculty. And faculty probably have ID numbers, and they have names, and they probably have departments, for instance, and they also probably have emails and so forth. So you know, phone number is another one. But I might want to kind of cluster these different types of data in different spreadsheets because they're kind of apples and oranges. There might be some overlap, but they're distinct, and so I have different sheets. In the database world, you do the exact same thing, except you call the whole thing a database, and you call these things tables, to be clear. But more importantly, with a real database, so to speak, you have to be a little more proactive about telling the database what types of data you want to store. Now, those of you who've used Google Spreadsheets and Apple Numbers in Excel know that you can go to like the Format menu or the Data menu or whatever, and you can show things to different decimal places. You can turn things to percents, and you can format the data. But that doesn't tend to have any functional impact on your data. It's just an aesthetic detail, like how long or short do you want to show the numbers to be in your columns and cells. But with databases, you can actually provide juicy hints to the database that will help that database store and find data for you more efficiently. For instance, there's this laundry list of data types to which we have access in SQL. So SQL is the language with which we're going to be able to query a database. Frankly, in something like Google Spreadsheets and Microsoft Excel, how do you find data? Well, you usually hit like Command F or Control F, and you search for it. That's not very programmatic. You can do it with macros and such, and we'll do this with code. But with SQL, you're going to have to make a few decisions first. SQL supports a few different data types, at least in one of its forms. So it turns out there's a lot of competition out there. SQL is a general language, but different companies and different nonprofit groups have come up with their own dialects. So much like we humans might speak, bunches of us might speak Spanish, well, there's different variations of Spanish, not to mention many, many, many other languages. And so similarly in the programming world, is there's sort of a common subset subset of words in a language, but then different companies and different people might have added and subtracted their own features just because they think that's better for their use cases. So in SQLite, which is the database technology we will use in CS50 IDE, and Android uses this, and it's very popular in other contexts too, iOS as well. They only have a few data types: blob, of all things, integer, numeric, real, and text. Now, what does that mean? Well, it turns out it means different things with different databases, and another popular database is called Postgres, or PostgreSQL. This is a very popular one for high-performing websites. So if you're trying to build a business, or you're trying to make an application used by everyone on campus, generally you would use a fancier technology than SQLite, which is by definition lightweight, and you'd use something like Postgres. And so we'll introduce you to both of these dialects along the way, because each of them allows us to do different things with a different degree of precision. So in SQL, let's claim, even though it's a simplification, there are at least these data types. When deciding what type of data to store in your database table, you have to decide not just what it's called, like ID and name and email and dorm. You have to decide what data type it is. So we've kind of come full circle, because the last time we did this was in what language? C. So in SQL 2, you do this, but it's not to be nitpicky. It's to actually improve performance. So this is to help you get at that data more efficiently, because the more the server, the database, knows about your data, the faster it can find it, essentially. So in the world of databases, you generally have to decide not just to store an integer, but either a small int, an integer, or a big int. And generally speaking, at least in most databases, this might be 2 bytes, this might be 4 bytes, this might be 8 bytes. So let's maybe impress the families here. If you have a 32-bit integer, or 4 bytes, what's the biggest integer you can store in your database? 4 billion. Someone, please, impress? 4 billion is exactly correct. And it might be 4 billion positive values, or maybe it's only 2 billion if you also want to have 2 billion or so negative numbers as well. Big int uses 64 bits, which is just massively, massively bigger. And tiny int, or small int rather, there's also tiny int in some dialects. Small int is just 2 bytes, and it actually counts up as high as 65,535. As I alluded to earlier. So you just need to decide. Now, why would you choose one over the other when you could just use big int and store small numbers and big numbers alike? Well, why might you just intuitively not want to make all of your integer values in a database big ints? It's just simple. Give me as much headroom as I want. Yeah, you're just using memory unnecessarily, right? Why use more memory than you need to? Now, arguably, God, memory is so cheap these days. Computers are getting bigger and faster. So in some contexts, it's not a big deal. But if you have lots of data, and every one of your rows in a database is 2 bytes bigger than it needs to be, and you have 1 million rows, I mean, that's already huge numbers of bytes that you're just wasting and throwing away. So it behooves you to actually give some thought to these data types. Of course, you don't want to go too small, because if you use a small int, or maybe even an integer, but business is so darn good that you have over 4 billion users, or 4 billion rows, or 4 billion foos and bars and bazzes that have been sold, which absolutely happens to the Googles and Facebooks of the world, you better start using 64 bits to represent unique values instead of just 32, because eventually you'll run out. Well, what else? Besides integer values in SQL, you might want to use floating point values. Those are real numbers that have decimal points in them. This is quite like C. They're called a little something different, and annoyingly it uses 2 words in this case. But a real number is a 32-bit value that is a floating point value, like a float in C, and double precision is like a double in C, which is 64 bits, and that just lets you get even finer grain control over the decimal point, as we've seen, because of course you can't represent numbers precisely because of imprecision, as we've seen in both Python and C. Numeric is kind of a catch-all for a bunch of number-related things that aren't quite integers or reals necessarily. Boolean, a true or false value. Date, if you want to literally store like year, 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 dash month, month, dash day, day in a standard computer format, even though human cultures vary how they write that. Date time, if you want to have a date and a time right after it. Numeric is actually a solution to a problem. Turns out that finally, after all this time, we have a built-in mechanism for storing numbers precisely. And this is perfectly timed, because in CS50 Finance, when you're dealing with money, it'd kind of be nice if you don't accidentally round off how much money someone has, either slightly lower or slightly higher. Those of you, maybe families especially, because from a few movies back in the day, if you ever saw Superman 3, this is how some money was made by shaving fractions of pennies off of computer systems. And more modernly, Office Space did this as well, big scam, trying to round off these pennies. Well, if you use the right technology and language, With SQL, you can actually specify a numeric data type, which is like a floating point value, but you specify essentially the total number of digits you want to handle and how many of them should be after the decimal point. So it's common in stock markets to actually use 4 decimal points of precision. So not just cents to the tenths and the hundredths place, but to the thousands and 10,000s place. You can now specify that with a value of 4 for precision. And you don't have to worry about those round-off errors we talked about before. Time and time stamps, just how much time has passed since a date and time, are also available to you in SQL. And then lastly here, text values. Turns out you have a choice of values for when it comes to deciding how many characters to use to store your data. You can use char, which just like in C with an array, you have to decide in advance for a string how many bytes to use. And if you say char 8, you are getting 8 bytes. And if the name is Malan, M-A-L-A-N, you are wasting 3, or if we null terminate it, 2 of those bytes. But SQL introduces a solution that Python kind of gave us too. Varchar, as the name kind of implies, variable number of chars, allows you to specify just an upper bound. So if you know that one of your columns is going to be called name, and a person's name might be M-A-L-A-N, like 5 letters, or maybe certainly more for people with longer last names or first names, you can say varchar 100. And that's the upper bound on how long it is. But the database will be smart. If you only need 5 characters or 5 bytes, it won't waste 95 others for you. It will optimize that for you. And then lastly, text. If you want to store tens of thousands, like paragraphs or pages of text, that's even bigger than varchar, where you don't necessarily want a well-defined upper bound. You just want a good chunk of memory. But there's implications here. And just quickly, char and varchar seem like not even complementary. Just char seems unnecessary. Why paint yourself into a corner and say, give me only 8 bytes, when you could just say, give me up to 100 bytes, and you, the database server, figure out how many to actually use? Like, why do these 2 data types exist? Yeah? Time? Yeah, so time is spot on. It might actually take longer to use one data type or the other. How could that possibly be? Well, if you've got a value like char, where you specify a precise number of characters, like 8, if you think about the columns in Google Spreadsheets and Excel, every one of those columns, cells, is exactly the same width, right? It's 8 bytes, 8 bytes, 8 bytes, 8 bytes. And as soon as you have perfectly constant offsets, this is byte 0, this is 8, this is 16, this is 24, this is 32, and so forth, you reintroduce the capability that in C we had with arrays. You have random access. Doing simple arithmetic, multiplication, addition, and subtraction, you can just jump to any element in a column if it's using the same number of bytes for every cell. But with varchar, if you need to have small, very narrow cells and wide cells, you're going to have what's called a ragged array, where one side of it, the left-hand side, so to speak, is going to be very straight and rigid, but the other side might kind of vary based on how long the word is in that column. And to your point about time, it's going to take the computer more time to search a varchar field because it can't just jump to the third element. It has to search all of them potentially. But thankfully, at the end of the day, databases don't do that. They don't just evolve into linear search. CSVs evolve, for our purposes, into linear search. The magic and the sort of intellectual property and the secret sauce, so to speak, that goes into databases, Oracle, SQL Server, Microsoft Access, Postgres, MySQL, and SQLite, is that really smart computer scientists have decided to implement algorithms and fancy data structures, often tree-based. If you recall our discussion of binary trees or tries and hash tables and those fancier data structures, they have baked those kinds of data structures and designs into their database software. They've made it freely available or commercially available. And so we now just have an abstraction called a database into which we can store data and just read it, update it, write it, and change it quickly without having to implement all of that low-level plumbing ourselves. And so that's ultimately what a database is going to give us, but we have to actually have access to a database to do that, and we need to actually decide first to help the database by telling it what to store where and how to store it as a type. So why don't we do this? Let me go ahead and do exactly that with a couple of examples. Let me go ahead and open up CS50 IDE again, our web-based programming environment, and let me go into our terminal window. So for those unfamiliar, a terminal window is just this black and white or this blue and white window in which you can type commands. And rather than point and click and double click on things, you can only do things textually in this window. And it turns out that in the world of SQLite, we can actually use a command called SQLite 3, which allows us to create a database. So in our human worlds for CSVs, you've seen how in code you can just create rows and columns. You can literally type it in a text box. SQLite is a database technology that uses binary format, zeros and ones. And so you're going to have to actually store your data differently using a program. So if I want to make a file called, for instance, frosh.ims.db, I can literally say SQLite 3 frosh.ims.db, and then I'm in this program. This is a text-based program via which I can create my rows and columns. And it, by design, is going to be a little arcane for a moment. It's going to look a little cryptic. But if I want to go ahead and create a table, like a spreadsheet in here, I'm going to literally type create table. I'm going to call this registrants, just like last week when we were looking at Frosh.IM's examples. And the freshman intramural sports program has students registering for sports. So I'm going to have a registrants table here. I'm going to go ahead now and specify that I want a few columns for this database table, one of which I want to call ID, one of which I want to call name, and one of which I want to call dorm. So I'm going to keep, whoops, I didn't mean to hit enter. Let me just clean this up. OK. That never happened. So now I have 3 columns, ID, name, and dorm. And if I were to hit enter, theoretically, it should create a database. It's not going to be graphical like Excel or Google Spreadsheets, but it will exist in my IDE in a file called frosh.ims.db. But I can't just hit enter yet, because I have to tell the database a bit more. I need to tell it that, you know what, my ID value should probably be an integer. And you know what, my name should probably be char or varchar. What should the name of a student be stored as? Varchar? OK, so varchar, because they're going to vary, right? If you can think of bunches of your friends, they might have short names or long names. OK, what's the upper bound? What's the length of your friend's longest name? 16? All right. Is anyone in here having a name, first name and last, that's longer than 16? Oh, 50, sorry. I heard 16, I thought. Because you're not going to be able to register for Frosh.IMs because the database is going to truncate it. And as an aside, if you've ever gone to a website and tried typing into a form field and either your keyboard stops working or you do type a long word or paragraph in and then you hit enter and some of it's gone, well, that's because the database likely can only store so many bytes. And frankly, this often happens on customer service forums, right? If they don't really want you being too verbose with the customer support staff, they'll cap the length of the field into which you're typing. And they're also doing that on the database, but also probably for practical human reasons. They don't want to read a big complaint that's this long as well. So 50. Anyone have a name longer than 50 characters? Yeah, not many names, but you know what? We have technology to answer this. Longest name in world. And it's this guy. Guinness Book of World Records is probably right. So his name is Barnaby, Marmaduke, Aloysius, Benji, Cobweb, D'Artagnan, Egbert, Felix, Gasper, Humbert, Ignatius, Jaden, Casper, Leroy, Maximilian, Nettie, Bajulo, Pepin, Quillum, Rosencrantz, Sexton, Teddy, Upwood, Vivatma, Wayland, Xylon, Yardley, Zachary, Usansky. But he also goes by Nick, apparently. But OK, let me go ahead and highlight this. And I could count this manually, but I'm sure someone has made a website to count characters in a string. There we go, lettercount.com. OK, let's go ahead and paste that in, count the characters. 225. So Nick will not be registering unless we don't support just 16 or 50. Looks like we need at least 225. So at some point, you do have to make a decision. And honestly, it's not always obvious. You do have to specify that varchar is going to be, could be 16, could be 50, could be 225. But you know what if he has kids? So let's just round up a bit and call it varchar 255, honestly, only because it was a convention. So back in the day, 255 tended to be the max length for this field in older databases, and that at least feels like it's probably enough wiggle room for names. But you have to make a judgment call at some point. We could ignore the problem and say 1,000 characters. But if that's never really going to happen and you're potentially wasting space, you probably shouldn't, because even though it's an upper bound, you're sacrificing something like time potentially to search that field if you're just telling the database that it's going to be bigger than it ever actually will be. It needs to be more finely hinted. So what about dorm? Oh, God, now we have to do this again. How do we do it with dorm? What's the longest length of a dorm or a house on campus? I don't like what Pforzheimer house maybe. But honestly, at some point it doesn't matter too much. But being consistent is what matters. It's a matter of style. It's a matter of design. At some point, you don't have to nitpick every little value, but you should probably pick some reasonable value that you could justify to a roommate or to a colleague or to a teaching fellow, and then say this feels like enough without it being actually excessive. And there's one last thing I'm going to do here is just end my thought with a semicolon. I apologize. They're back. But at the end of my thought here, if I haven't made any typographical errors, and I'm going to go ahead and hit enter, nothing seems to happen. And ironically, in CS50, in programming, nothing happening is usually a good thing because it means no errors have happened. If in SQLite I type schema, I can actually just see a regurgitation of the table I just created. But more importantly, I can start to insert data into this. Now, unfortunately, it's not yet graphical, but if I want to insert data into this, I can do this. Insert into registrants. Well, what do you want to insert? I want to go ahead and insert an ID, a name, and a dorm. Well, with what values? Well, with these values. The ID will be, the first registrant will be 1. The first one to register will be Brian. And his dorm, Brian, where'd you live? Pennypacker. So it's good. That might be close to Pforzheimer too, lengthwise. So I'm going to go ahead and do this. Here is an example of a SQL statement. Create table is one verb or expression you can use. Insert into is another. You specify the name of the table, the fields of the table, and then values. And now I'm capitalizing just to make clear what are SQL commands and what are actually just words I, the human developer, chose. But it's just a convention. These uppercase words could probably be lowercase in most contexts too, but it helps things, I think, visually to distinguish. Now I go ahead and hit enter. Nothing seemed to happen. That's probably a good thing. Let's go ahead and register one other person. I'll be the second registrant. So maybe David from Matthews. And so Matthews here, enter. And now, if I want to select all of the students in the database, I can go ahead and say select from, or you know what, let's select everything, as denoted in many languages by star, from registrants, semicolon, enter. And there we have it. It's kind of a tiny, super simple, lightweight database, but there are my rows and columns, much like Excel and Google Spreadsheets would lay them out for me. But it gets better than this. Suppose I want to search this database for all of the students who registered for Matthews. And suppose that time passes and more students actually register for Frosh IMs. I can actually filter this data. I can do something like select star from registrants where dorm equals, quote unquote, Matthews. And so I can filter it, hit enter, and now I get back just one row. And if your mind starts to wander, wow, if I could introduce Python or JavaScript into this, you know what I could do? I could probably get back not this ASCII-based table, this text table. Maybe I could get back an actual list of rows so that I can actually do something with that data. And that's indeed where we're going with this. So if I want to select someone else, I could do, maybe select just the name from registrants where dorm equals Matthews. If I only care about knowing who registered, I could do that and whittle it down to even less data. So already in just these few commands, I can express so much more functionality than you could with a CSV. To do this in CSV, you would have had to write all of these lines of Python code yourself. What if Brian moved? So Brian really didn't like the union dorm, so we're going to go ahead and update registrants and set dorm equal to, where do you want to move to? Canada, where I could do this a few ways. What's your instinct? How could I identify Brian and only Brian? So I don't want to move to Canada. How do we move just Brian? Yeah, maybe we could do, where name equals quote unquote Brian and enter. I like this, but someone find fault with this if you could. If there's two Brians, we're moving both of them or all three of them. So maybe better, honestly, would be to say, let's just say where the ID equals 1. Now, of course, I know you need to know Brian's Harvard ID number or whatnot, but this is going to be more precise because the supposition here is that the leftmost column, our ID field, by human convention, should be unique, so that it uniquely identifies the room so we can have as many Brians as we want, but we're not going to confuse them. If I go ahead and hit enter now, nothing seems to happen. But if I select star from registrants again and hit enter, notice now Brian has indeed been moved to Canada. So there's so many other things. Brian, you know what? You're not very good at sports, the team concluded. So delete from registrants where ID equals 1. And now if we select star from registrants, we have, I guess, just me left. but Brian is gone as well. So we have the ability to insert, to select, to update, and delete, and create, all the while filtering. And we've only just scratched the surface here of what's possible. Because it turns out we can store so much data in these databases. All of our students, all of our faculty. If you're a company, you can start to store all of the products in your database, all of the orders, all of your customers. But as soon as you start going down that road, well, gee, what's a customer? Customers have names and ID numbers, and maybe email addresses and postal addresses. Those are going to get messy. Phone numbers, which are kind of like integers, but not quite. So there's so many questions we still need to answer. But feels like it's time for some fruit and some muffins. So why don't we go ahead and take a 5-minute break, turn on some music. If parents need to depart, that's fine. And we'll see you back here in 5 or so minutes. right, so we're back, and where we left off was exactly here using SQLite 3, which is the version 3 of the SQLite command, which is just a text-based interface to the technology that we should think of as SQLite. SQLite is interesting, and it's lightweight in the sense that it's not a server, it's not fancy software that you have to run. It literally stores all of your data in a file, but that by convention ends in .db or maybe even .SQLite, but it's just a binary file, zeros and ones. It's not text that you can open with Excel or something like that, so it's not a CSV, so it's stored on file. This means that you don't need particular experience with setting up a database server. You don't need memory and software to actually run on the computer. You can store everything locally, but you do pay a price because, recall from our past discussions, disks are slow, and if you're storing your data on the disk, it's not going to be nearly as fast as storing it only in RAM, and that's why these other technologies like Postgres and MySQL and Microsoft Access and SQL Server and Oracle exist. Those are fancier products where someone literally does double-click an icon or run a command that runs a program that stays running in the computer's memory and gives you even better performance. But for our purposes, pedagogically, SQLite is handy, but we're still going to ask the questions about data types because SQLite does support fancier data types like those in Postgres and SQL Server and MySQL and Oracle, and those are the lowercase ones we introduced a bit ago. But honestly, this is going to get tedious quickly. Like, even I rarely remember exactly the right syntax when creating tables, the order in which everything has to go. So I tend to use a graphical user interface, or GUI, myself. And there's lots of tools out there, but we've built one that's free and open source into CS50 IDE that just makes it a little easier to edit your SQL tables. So I'm going to go ahead and exit out of SQLite. Exit out of SQLite. And I'm going to go ahead over here. And you'll notice that we have all of the files from today, including, most recently, froshims.db. That is the file I created with SQLite 3. But if you double-click it, when using CS50 IDE, it's actually going to open a program that's called PHP Lightadmin. It happens to be written in another language called PHP. Has nothing to do with databases, just the name of the product here. But it's a tool that, using pretty simple HTML tables, just gives us a graphical user interface over the exact same functionality. And personally, I just find this easier to use. And pedagogically, it's going to be better because it's going to show us the available data types for our table. So for instance, notice here, there's a lot going on the screen, but a lot of this is just uninteresting details. But notice here, I see a table called registrants, and then I can browse it. I can see its structure. I can execute manual SQL by typing it in. I can search it, insert. I can do bunches of things to it. And that's why this graphical user interface is just convenient. Let me go ahead and click on registrants. And by default, you'll see these tabs now: Browse, Structure, SQL, and then a bunch of others. And notice over here, you'll see the one row and the one registrant who actually remains, because when we last left off, we removed Brian forcibly from the team. So suppose I want to go ahead and add more rows just for the sake of discussion. I can just do it manually here. I can go in here and I can say, let's say the third player is going to be Veronica. I think she was also in Matthew, so I can just type that in here, and I can just go ahead and click Insert. But what's nice about PHP Lightadmin is that it will not only insert the rows for you, it will show you the SQLite code with which you could have done it yourself. So it's a nice visual reinforcement of that exact same command. And you'll notice they use double quotes instead of my single quotes before. They're sometimes interchangeable, but not always. So it's a wonderful way of just learning how you can actually do this with the right SQL code, so you're not oversimplifying it with the GUI. But you know what? Let's do this. I'm going to go ahead and start over because I want to make some better decisions. I'm going to go ahead and literally right-click or control-click this, delete froshims.db, and let's actually start this from scratch. Now, previously when I did this, I could have, in my terminal window, gone ahead and done SQLite 3 and then, froshims.db and created the file. For now, I'm going to actually just go ahead and touch a file called that name, which is a simple command that just literally creates it but puts nothing in it, just so I have an empty file. And you'll see that it just popped up again on the left-hand side, which is handy. And now I can double-click this version of it, which has nothing in it yet, and I'm back to PHP Lightadmin. But notice, no table in database. So let's start to ask some of the harder questions as to actually how to create data in a database. So let me go ahead and go to this field here, create new table on database froshims. I'll go ahead and call it registrants again. But how many fields? So let's go with ID, name, and dorm. What else? Email, I heard earlier. Age, I heard earlier. So sports you want to be in. OK, 6 fields. Let's go with that. So it's actually, you know what, 7 fields. I want phone numbers too this time. So let me go ahead and click Go. And now you'll see just a GUI way of prompting you for all the answers to the same questions as before. And maybe this is clear, maybe it's not. But it's just an alternative to the memorizing exactly what the commands need to be. So top to bottom, here's all of the fields I need to decide on. Ironically, the fields is just a synonym for columns, and yet my columns are currently laid out in rows, but that's just a UI issue. So let me go ahead and decide. By convention, my first field is almost always ID, or probably should be, and we'll see why this is powerful in just a little bit. The data type for that, by convention, should be integer, unless you've got a lot of data like a Facebook, and then big int might make more sense. But notice this dropdown actually gives us a nice menu of options just as before. And you'll see in gray text the category, or in fancy terms, the affinity of these various types in SQLite. And in lowercase black words here, you'll see the actual data type supported by big popular databases like Postgres that you might want to use for your final projects. In fact, we're introducing these with an eye toward you're using these for final projects in the cloud, not in CS50 IDE, but actually getting your own domain name and putting your website, if you do a web app, out there. So here we have all of my available types, and under integer, I'm going to go ahead and literally choose integer for my ID. All right, next go ahead and zoom out. Let me go ahead and choose a student's name. Before, did we decide on char or varchar? OK, varchar in what size? 255. So the user interface here just allows me to type it in. So the syntax is a little different because it's a GUI, but 255. But you know what? The last field was dorm. That too, I think we said varchar. So let me choose that. And 255, though this one's a little more debatable. I'm not sure what the right number is. So in the absence of clarity, I'm just going to standardize on some same value without being too wasteful. But notice there's a few questions here that we haven't come to, but our perfect segue earlier hinted at this. It turns out you need to make a few other decisions when designing a database. If you know in advance that one of your fields is like the primary piece of data to uniquely identify users, that's what's going to be called a primary key. The column or field that guaranteed is going to identify users uniquely. So if you've got 2 Brians, each of them is going to have its own ID. That, therefore, is your primary key, not the name field Brian. So I'm going to tell the database this is the primary key, and it's going to help me keep track of that uniqueness. Moreover, this is a fancy feature. Before, I was manually and very arbitrarily saying, Brian will be number 1, I'll be number 2, Veronica will be number 3. That's tedious. Like, computers should be able to solve that problem for me. I don't want to think about who is ID number what. You can auto-increment a field. So if I actually check this box, SQL for me will just plus the ID field every time I insert a new name and a new dorm. I don't have to even bother specifying an ID anymore. Now, there's another column here, not null, where you can specify this column should never be null. And this is important because if you're building a website that has important data that you must have from the users, like your app won't work without the user's username or their password or their email address, you can say not null, and your database will ensure that you can't even insert a row into this database unless you give it a value for that field. So it helps you protect you against yourself, because you could certainly implement that logically in Python or any language, but the database is a final gauntlet as well. A default value doesn't really make sense here, but for certain types of fields, you can say database insert the current time or the current date for me. Now, why might you want that? Why date and time by default? Why might that be useful? When the account was created, when they bought a foo, when they shipped the bar, any number of reasons. You might just want to know what is the time right now. Well, you don't have to write code for that. The database can answer those questions for you. So just so much more functionality than we got, of course, with CSVs alone. So name, should it be a primary key? No, otherwise we couldn't have 2 Brians. And generally, your primary key will be 1 field, though theoretically you could make joint columns if you wanted. But generally, it'll be a single one. Should we auto-increment Brian? So it's like, well, we had Brian 28, or Brian 2, Brian 3, and so forth. No, doesn't really make sense. Not null. Probably I want all of the freshmen's names so that we know who is signing up for sports. And dorm, yeah, not null. But, oh, corner case. Can anyone think of a corner case where dorm maybe should kind of sort of be null? They commute, they're off campus. You know, it's not many students, but if you have 1%, 5% of students living off campus, this is a design question now. And all of us have probably visited some website where you just can't fill out the form in the right way because you don't fit their mold or their expectations, and that's just because of a poor design decision. So let's allow it to be null just in case. Now, what else we said? Phone number was one I proposed. Gosh, there's no phone number type. So what do you want to go with? Sorry? Varchar. OK, so we can pick varchar and maybe use like 10 or so for 10 digits in the US at least. Though maybe like 12 with the dashes or 13 with the parentheses or what's that? Oh, I hear murmuring. Sorry?
Small int.
A small int and just treat it as a number. Maybe that could work too. Another alternative. Anything else? A precision. So a specific number. Good. So not a bad instinct, but it turns out with the numeric data type, where you specify scale, as it's called, the total number of digits in precision, that's generally meant for floating point values, so real numbers with decimal points, because even though you're specifying a max limit, you don't require that many digits. It's just a max. Yeah?
I mean, I would think that giving it, like doing some sort of chars may not be bad design, because then you can enter non-numerical values.
Yeah. We can kind of find faults, I think, in both of these ideas, though both of them are reasonable. If you allow for char or varchar, I could type in like foo or bar or baz and not a number. So maybe we should go with int. But can someone think of a counter example to why you shouldn't use integer?
It's got a variable length to it, so you can get whatever number.
Variable length, but if we actually do the math, maybe 65, maybe there's enough bytes there. Or we could use a big int, and that gives us a really long phone number. So there's probably a reasonable max, yeah?
Let's say you want hyphens in between more parentheses.
Yeah. Hyphens and parentheses, we have to decide, do we want to support those? And honestly, all of us are perhaps a little US-centric right now, but most of us here. But you know, when you make a local call in some zones, like you type 0 first, and some human might type 0 as their number. But what's going to happen if you type 0 into an integer field? You're going to ignore it. So now there's that corner case. So damn it, like there's no way to solve this problem, it would seem. So what's best? We have to make a compromise and just accept that we have to solve this with code. Varchar? All right, so varchars. Or char. All right, so let's simplify the problem. No one from outside the US can take freshman intramural sports. That simplifies the world, because if we only support US phone numbers, now we can say 10 digits. And if we say, you know what, I don't care about the hyphens or the parentheses, I can use code, JavaScript or Python, to throw away the syntax, and I can just store 10 digits. Maybe char 10 is sufficient. 3 for the area code, then the rest of the number, all 7 digits thereof. But you could find fault with this too, and we're really alienating the international population on campus. And so, but again, these are just non-obvious design decisions. And so here we are at the end of the semester. We don't always have good answers, and reasonable people will disagree. But let me simplify our assumptions and just do US numbers, 10 digits, and trust that I will use code in Python or some other language to throw away the syntax, the punctuation and whatnot of parentheses and hyphens, and I'll make sure the human hasn't typed in any letters of the alphabet. I can do that in code, and you know we can do that even in JavaScript when the human submits a form. We'll leave for the end sports. What was it? Sports. Sports they might want to do. So this is a good example of you shouldn't really have spaces in your field name. So the convention would be sports, they, really, or might, or let's just call it sports in this case. We'll come back to that. I think there were 2 other ideas we had. Phone number. Email. OK, email is a good one. What should that one be? There's no email type, unfortunately, even though there is an HTML, an input type for email. What's that? Var. Yeah, var. I feel like we probably need a varchar here. But here, a little non-obvious. What is the longest email address in the world? Maybe it's Nick's? Yeah. Nick's. So I don't know, but let's pick a reasonable upper bound that we can maybe be comfortable with as a group. Let's see. Anything else here? No? OK, and then was there one more field? Oh, how about age? Let's go with age. So age, finally, something simple. What do you want this to be? Small int, right? So you're not going to, we will not support people older than 65,535 years old. Someone want to find fault with this idea, though? I would argue there's no one right answer to any of these. Month, well, but it depends. Do we want month?
Yeah, we might need 12
So you're assuming we want birth date. I think I've called it age, so maybe that's the problem. Like if it's age, small int's fine. Like you can be 0 years old or 65,000 years old. We have a good range. If it's age, I think we're OK. But I think you allude to a good point, which is why would we maybe want to store birth date and not age? Yeah, the damn thing's always changing otherwise, right? Like, I'm going to have to update my database tomorrow and then the next day, let alone every hour or every minute, just because my users' ages are changing. Like, that seems silly. Let me instead fix a value. So do something like birth date, maybe specify not an int, but let's actually use the date field, not time. We could store time if we really care what time they were born on a certain day. But here I can say date is going to be a little better because now I know in Python, JavaScript, even C, I can do a little bit of math. And if I know they were born on such and such a day and month and year, well, I'll just subtract that from the current day, month, and year and figure out how many days or years old they are. So a better design decision there, perhaps. But we do have to standardize the formats. We can't just allow people from the US and Europe and Asia to all kind of choose their own formats. SQL standardizes this. Year, dash month, dash day. And that's the value of having these data types again. All right, so how about sports, the last one? Varchar, all right. What's the longest number of words in the sport?
I did say might want to do so it could get up there, but 255 probably makes the most sense.
Maybe, unless they're very athletic. Yeah, here too, I don't know, but just for the sake of opening up possibilities, when you think the human might be a little expository and actually write a paragraph of all of the sports they're involved in or whatnot, or even bigger than a paragraph, text is even bigger. Sports, this probably isn't compelling, and I'll change it back to varchar. But if someone is typing in like their college essay into the Common Application, or if you're asking people to paste their resumes or the like, you might want to use text because I have no idea how many words someone's going to have. Text allows you to store even more data, but it stores it a little differently. It tends to store it not in the column, but using pointers, if you recall, from a few weeks back. It uses the equivalent of that to store it like over there, which takes a little more time to get to. So again, there's just a trade-off here. So we could do varchar. 255 makes me a little nervous, so I'm going to go with another common value, 1024. It's a power of 2, but there's no one right answer here. But these are the non-obvious design decisions we have to make. If I didn't make any mistakes here, I'm going to go ahead and click Create, and whew, table has been created. You can even see now all of the data that's been created there. And voila, if I go back to Frosh IMs and I go back to the registrants table, not only can I browse it, there's nothing in there yet, I can look at the structure and actually see all of those same values and edit some of them, like renaming, but you can't completely mutilate it. You might have to start over if you make too many changes. All right, any questions then about this? Yeah?
Why do you use 1024 instead of 1023?
Why do I use 1024 instead of 1023? Typically, when you choose a convention. I can't justify this. 255 was the max because I think one of the bytes was reserved for some value historically, but that's not really the case. That bound has been lifted, and no good reason. Nowadays, yes. Back years ago, 255 was an actual limit, and so it got adopted. Now, I don't know. I just pick powers of 2 often. My next go-to would be 2048, 4096, and so forth, just because. Yeah?
What's the difference between varchar and char?
Varchar, what's the difference between varchar and char? Char uses a fixed number of bytes, no matter how many of them you are using. The advantage of which is your columns conceptually are perfectly straight on both the left edge and the right edge, which means you have random access because every cell is some fixed number of bytes from the rest. Varchar uses like a ragged array, as it's called, where one side, the right-hand side, is shorter or longer in different cells, so there's only a maximum length on each of those cells, but searching it can be slower as a result because you can't just jump to cell. You have to follow the lengths of those things. That's the trade-off. Yeah? Oh, if I wanted to add an education field now and modify the table, if you realize too late, oh, darn, like I need to actually add something to this, in the GUI tool, we can add one field to the end of the table, literally. So let's do that. Let me go ahead and click Go. I'll be prompted with a similar form, but smaller. I can go ahead and type in something like education. Let me propose this is varchar, maybe 255, though we could have that debate too. I'm going to go ahead and say add field. And now, notice that the table has been altered successfully. It's for whatever reason, it's not showing me the code for that particular command, but there's literally an alter command in SQL that would allow you to change it. And if I go back to the structure now, you'll see that I have another column called education, shown ironically here as a row. Yeah?
Is the order of columns
Good question. Does the order of the columns matter? Fundamentally, no. By convention, you would typically put the ID first, and then I personally, by design, put like the most important fields next, like name feels like the right choice, maybe email feels like the right choice, though I clearly thought of it a little too late this time. It's not easy in SQLite to reorder things, but in other databases you can. So there, it's more of a human convention. Yeah.
Is it convention to have one single primary key, or can you have multiple?
Good question. Is it a convention to have one single primary key, or can you have multiple? By definition, you can only have one, but that primary key can span multiple columns. So we haven't seen a use case for this yet, but there are scenarios in which you would want to say, I want to guarantee that these two columns together are unique, but not each individual one unique. But we won't encounter that just yet. Other questions? Yeah?
What if you had added education after you already had started the database and that was a not null field?
Really good question. What if you had added education after you already had real data in there, but you specified not null, which is problematic because what is the educational backgrounds of the previous people? Typically what the database would do is either reject it or it would just put the empty string, quote unquote. So it's not technically null, but there's nothing actually there. It's just a string of length 0. Really good question. All right, so what can we now do that's a little more powerful about this? Well, let me go ahead and quickly insert some data here. I'm going to keep most of it blank, but you know what? I'm not even going to bother with ID. Brian, you're back on the team. Let's go ahead and insert Brian. Let's go ahead now into registrants again. Let's go ahead and add Veronica again. So I'm just inserting a few rows manually. And again, notice it's executing all of this for me without me having to bother typing it out, but I absolutely could. In fact, just for good measure, let's do one manually. If I click the SQL tab, notice that I get a default suggestion here. That is the syntax with which you can select everything. Or I can just type insert into registrants. But now if I only want to insert a name, I don't have to do all of the columns. I can just say, go ahead and insert here Aaron, for instance, semicolon, zoom out and click go. That seemed to work. If I go back to browse now, Aaron is in there as well. But you'll see the difference. The query that's being generated automatically by the GUI was lazily just inserting quote unquote, the so-called empty string of length 0. I, by omitting even mention of those columns, was deliberately inserting null. So frankly, my database is getting a little messy here. So you generally don't use PHP Lightadmin or a GUI to insert data. You might use it to conveniently create your tables and kind of get your application ready. But then you're going to write code ultimately. And that's the direction we're going. I'm going to go ahead and insert one more person. Oh, I forgot. I'm not on the team at all because we started over. So let me put myself back on the team. David, and let me go ahead and click insert, go back to registrants, and now you'll see there's 4 of us. My ID changed because they've been inserted in different orders, but notice all of the auto incrementing has been happening magically for me. And that's useful because I don't have to even think about it, and who cares what my ID is? I just need to have, in many cases in a database, a unique ID. So now let's actually write a little bit of code, right? Thus far, we haven't done anything useful. We've shown you like this black and white window in which you can like select, insert, and update data, but that doesn't really solve any problems we know about yet. We have this graphical web-based interface via which you can create tables and add data, but who cares? We're trying to solve actual problems. And the problems of late have been to build software that would solve any number of human problems, like surveying users and showing the results or finding similarities in documents. So suppose the problem at hand now is to actually build something like the Frosh IM's website and let students register and then see who is registered. Well, back in my day, I fairly lazily, for lack of technical know-how, just emailed the registrations to the proctor or the RA who was managing the intramural sports program. But they later started putting it in CSV files. Suppose now, version 3, 20 years later, I want to store it in an actual database. How can I actually do that and then see the results? Well, let me go into the IDE again and open up, for instance, a new file that I'll go ahead and call lecture.py. And suppose I just want to write a simple Python program via which to select data from a database. So it turns out I can do a few things here. First of all, let me go ahead and do, let's say, from CS50. I previously have done things like import getString and getInt and so forth. It turns out that the CS50 library for Python also supports SQL. And it's going to give us a function called execute that will let you execute any SQL command, but in Python code. So instead of pulling up SQLite 3 via my own hands or going to a graphical user interface PHP Lightadmin, I can write code that talks directly to frosh.ims.db and eliminate all of those tools altogether and just now write code. So how do I do this? I'm going to declare a variable called db for database, though I could call it anything I want. And I'm going to go ahead and call this SQL function. And I'm going to pass in a somewhat funky looking string as an argument, but it's a standard convention to say what database technology do you want to use. Then you do : //, so it's 3 slashes, not the usual 2 in a URL. And I'm going to specify frosh.ims.db. This now will give me a Python variable called database that is kind of like a portal, if you will, into that database file that I can send selects and inserts and deletes and updates to. How do I do this? Well, if at the end of the day I want to execute the equivalent of select star from registrants, how do I do that? Well, I'm just in a text editor, right? This is CS50 IDE. I'm just typing text. Moreover, I'm typing text in a Python file, and this is not Python. And indeed, the IDE has this little red X saying, can't do this. But I could pass SQL code as an input to a Python function and let that function talk to the database. And indeed, that's what we're going to get here from CS50's library. I'm going to go ahead and do this. You know what? Access the database and execute the following SQL code, quote unquote that, close parenthesis. Now, what does select return by convention? What should it return? Well, in SQLite 3, we just saw kind of a pretty text-based table, right, with like lines and slashes that looked like a table, but it was just text. PHP Lightadmin, we actually saw HTML tables when I browsed the database. And I proposed verbally a bit ago that, you know what, if I were to get back all of this data in code, what data type would I like it to be handed to me as? You know, rows. I want rows from a table. Show me all the students who've registered. What data structure in Python seems apt? Yeah, just a list, right? A list that's ordered from first row to last row. So we'll call that a list or an array back in the day of C. So you know what? I'm going to assume that's correct. And if I read the documentation, I would see that it's correct. CS50's execute function, if you use select, returns to a list of rows. It might have 0 rows if there's no matches, but it might have 1,000 rows if there's lots of matches. I'm going to store those results, whatever they are, in my rows array. Now, suppose I want to print out who has registered in my database from whatever frosh.ims website exists. I'm assuming students have registered on the web. Now I'm just the proctor or the RA who's actually now trying to manipulate the data and do something with it. So what can I do? Well, for row in rows, what do I want to do? Let me go ahead and just print out that so-and-so registered. So so-and-so registered. Well, how do I plug in so-and-so? Well, there's a few ways to do this. And let's see. First of all, I could use my placeholder syntax for print. And then I want to print out the row, but what do I want from that row? What columns are in any row in this database? ID and name and dorm and phone and sports. Well, it turns out those are going to be handed to you as Python dictionaries or dict structures. So I can just say row, quote unquote, name here. And I'll use single quotes just to make more clear what's going on here. And then I need to make one fix. How do I? F for format string. So it looks a little cryptic, but this is just Python stuff now. The only thing that's new is SQL. But if we stipulate that SQL, when using this execute function, it's just going to hand you a list of rows, each of which is a dictionary so that you can get at this column, ID or name or dorm. This would seem to be now a nice convergence of this week now with the past couple of weeks. So let me go ahead and save this. Let me go ahead and view my console so I have a terminal window. And let me go ahead and run Python of lecture.py. And in just a moment, if I cross my fingers, I should hopefully see who has registered. Amazing. I've seen who's registered. Now, there's one line of output that I didn't expect, which is just this one. This is the library just being pedagogically helpful. It's showing me every command that I sent to the database. But you'll see that so-and-so has registered. So this is kind of interesting. It's kind of a stupid program, right? Because most proctors aren't going to be like hacking frosh.ims by using a terminal window and running Python scripts. They're probably going to want to do this via a web page and actually see who is registered. But if we have the ability in Python code to do this, like iteration, what could I do instead of just printing to the screen? What could I print out per last week and per the past problem set? I could print out HTML, right? Like each of the students who registered kind of feels like an opportunity for like an unordered list or an ordered list or a table or whatever. You can now generate HTML. So let me do this. Let me actually go into an example I've made in advance and open up lecture here. And let me go ahead and open up, say, application. Well, let's see, what do we want to do here? What if I went ahead and opened up layout.html? Here is a simple layout for a web application using Flask. For those unfamiliar, this is mostly HTML plus a technology called Jinja, which is a web-based technology for generating websites dynamically. The body of this page is clearly what's of interest. And you know what? I bet I could do some logic right in there. So let me go ahead and do this. Let me go ahead and create, let's say, a new file. Let's call this application.py. I'm going to go ahead and, just for time's sake, do a little bit of copy-paste to save myself some keystrokes. But I'm going to delete most of it first. And now I'm going to go ahead and just save it here. So here's my starting point. Let me go ahead and import SQL, request. We got everything we need. OK, so here's a very simple web app. And this is going to be my to-do. And let me go ahead and copy myself. I'm just going to grab this from the directory that we already have for today. So let me copy from source 8 from my lecture example, a couple of templates here. And let me now go ahead and open these templates. So if I go in here to templates, let me open up index.html. And let me go ahead into here. So long story short, here's where we're going with this. What if I instead generate an unordered list using code from last week, but I use my for loop here inside of my web app instead of actually just with a simple lecture.py file? Well, recall that I could do something like this. I can have a Jinja loop, so I could say something like for row in rows, and then down here I can, preemptively say something like end for, which is our weird syntax from last week. And then in here, I can just do a list item. And then if I want to show who registered, what do I type here? Something in between these curly braces? If each row represents a registrant, row name, registered, I can just do something like this. So same idea. I'm just wrapping it with a little bit of HTML. Now let me go to my application.py file, because I'm going to have to fill in some blanks. And let me see, how can I do this? Well, ultimately, I want to return the result of rendering a template called index.html. For families unfamiliar, this is just a line of code that says go show that file to the user. But I don't want to just show them the file as is. But let's at least get this set up. I'm worried that it might not work yet because I need to get the actual data. So how can I get all of the rows from my registrants? Well, I can do rows get db.execute. And I can go ahead and select star from registrants and store that in there. This file is called froshims.db that I created earlier. And everything else is just Flask stuff from last week. Nothing else is new. The only thing that's new is this line here, and now this line here, where I'm using SQL inside of a Python call by passing it as an argument to a function called execute. How do I pass the rows to index.html? Yeah, like rows equals rows is the convention we've adopted. You could call it anything you want, x equals y, but this is a little more straightforward. So this is saying, hey, database, get me all of the rows from my registrants, and then render the template index.html and pass in these rows. And now, if I hold my breath and run Flask run, no syntax errors. If I go ahead and visit this here and open, damn it, the tab, I see an internal server error. So teachable moment, families. Let's go back into the browser window here and see what happened. OK, template syntax error. So pretty stupid mistake. It looks like I expected a square bracket instead of a curly brace. That's fixable. Let me go into index.html. And I didn't finish my thought. So that's some of the frustrations of programming for those who are seeing this for the first time. Let me save that. Let me go back to the browser here. And we'll just reload. Oh, my God. Voila. Now I have a web page via which you can see who has registered. But you know what? We can make this more powerful. Recall that we've been playing with HTTP for some time. And if this is the URL I'm accessing, recall that we played around with like re-implementing search functionality. Well, what if I want to support search such that I can just visit q equals and then search for people named, say, Brian and see how many Brians are registered? Could we add support for something like this? Well, maybe. Let me go back into the IDE, into application.py, and let me go ahead and say something like this. Q equals request.args get q to see if anything is actually there. And then let me go ahead and do this. Select star from registrants where, let me see, q, where what? Name equals q, but I need a placeholder, so maybe I should do this. And as soon as I do this, I need a what? F for a format string. So I could just create on the fly a SQL command that plugs in the value of Q between those curly braces to express the logic of select all of the registrants whose names equal Brian or Veronica or whoever's name I typed in. Let me go back to the browser here. Let me go over and do something like this now. Question mark Q equals Brian. Cross my fingers as before. Damn it. OK. And what did I do wrong here? What did I do wrong here? This is subtle. And we're seeing it for the first time. It thinks there's a column called Brian, but why would it think that? Well, what I've effectively done is sent in this. Brian is not a keyword in SQL, and because it's an actual string that I'm comparing against, what I really need to be doing is this. Otherwise, SQLite is going to think it's like the name of a column or something I pre-created. So we have to fix this, but that's OK. I can put the quotes there, but I should probably put the Q there in quotes. Let's save this, go back to the browser, reload, and there we go. Now we have functionality for Brian. And so with this basic building block, what have we done? Well, in SQL, we have several commands at our disposal. Creating a table, which frankly gets tedious by typing it out. I myself tend to use and recommend PHP Liteman just to create your table and get it going. But then you can certainly manually, with SQLite 3 or PHP Liteman, insert or update or delete or select information once it's actually in the database. And that's pretty powerful. But once you do that, you can now use that same new syntax, that new language SQL, passing it in as an input with a string to our execute function, and now start pulling any data you want from your database. Last week with CSV files, if you wanted to do this, you'd have to open the CSV file, use a for loop to iterate over it, look over every column and row for your data, then pass it in, and that's fine. That's correct. That's not bad, but it's tedious, and you're reinventing the wheel again and again, and there's no filtration built in as there is to SQL itself. So you now have a more sophisticated tool in your toolkit, so to speak, with which to solve that same kind of problem. Any questions then on this technique? All right, well, let's look at a bigger database and see where we can go with this. So if you go on the course's website, you'll see a larger database that's actually available in multiple formats. SQLite, which we'll see in a moment, but also Google Spreadsheets, because frankly, it's a lot more pleasant to look at your rows and columns in a GUI than it is necessarily with the file itself. So this happens to be a free and open source sample database. Like some guy years ago took his actual iTunes database, all the music he'd ever bought. He wrote a program to analyze Apple's file format in iTunes and extract all of the data that seemed to be stored about him, I think was the story, and just made it publicly available as a sample database for students and teachers to just use to manipulate data. But what's interesting is that this database demonstrates some other principles that we really haven't touched on. For instance, if I were to store again and again all of these students who are registering for Frosh IMs, what do you start to see in certain fields? Well, I was a little lazy and I didn't bother typing in everyone's dorm. But suppose that hundreds of students have registered for Frosh IMs. A lot of them are going to be from Matthews, some from Pennypacker, some from Canada, some from Weld, and bunches of other buildings on campus. It starts to get a little ridiculous when you see Matthews, 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 100 or more times. If there's 1,600 freshmen, there's a lot of kids in Matthews. That's a lot of bytes to store M-A-T-T-H-E-W. I don't know. Doesn't matter how it's spelled. That's a lot of bytes to actually store in your database again and again and again. Feels like there should be an opportunity to factor out the commonalities. And what humans do with databases is once they recognize a recurring pattern of data, same darn strings again and again and again, you know what? Rather than use now it matters, M-A-T-T-H-E-W-S, which is 8 bytes, or P-E-N-N-Y-P-A-C-K-E-R, which is 11, then we have a lot of bytes being used again and again and again to store all of these dorms. You know what? What's better than 11 bytes or 8 bytes? Let's just use an int. Or let's even use a small int, 2 bytes or 4 bytes, to represent dorms. So instead of storing Matthews, let's just store the number 10. And instead of Pennypacker, let's just store the number 11, thereby using some bytes but fewer and therefore saving bytes in the long run. And so what this database demonstrates is exactly that principle. Certainly when it comes to music, where artists have multiple albums and artists have multiple songs, it's probably a little silly in a musical database to store the name of the album again and again and again and again for all 10 or 12 or 20 tracks or songs on that particular album. So what this person did was this. Notice here we have a whole bunch of sheets, or in database speak, these would be tables. And notice that these tables have columns. And notice that these columns are album ID in the album table, album ID and title. But notice what he did very cleverly with this field, artist ID. Artists or singers have lots of songs to their name eventually. And so he's assigned each of them a unique value, or Apple did in iTunes underneath the hood. So how do I know what this artist's name is? How would you figure this out? I mean, it's not that interesting to us humans to know, ooh, artist ID number 2. This is just, what's that? Yeah, we need another table with artists, which is right over here. So let me go ahead and look there. So if I want to see, let's see, Let There Be Rock, artist number 1, let's go to the artist table. And turns out AC/DC, the band, is who created that. Now, we've added a step here, which maybe is costing us a little bit of time, but it's going to save us space in the long run if I'm not storing long artist names, although AC/DC isn't terribly long, again and again and again. Now, which is better? Well, it's a trade-off. Are you more comfortable wasting space and storing everything together, or do you prefer to save space and just spend a little more time joining the data back together? But it's going to be really annoying if I want to make a website that shows me the names of the songs that I have in a database and the artists for them, let alone the albums and more of that, the titles of the tracks and so forth, feels like that's 3 queries, right? Like select the album, select the artist, select the titles. But no, with SQL, you can collapse that all together. Because notice, in this table here, artist, there's a column called artist ID that's numbers. And notice if you kind of picture this, it's like the fingertips here, let's propose metaphorically, represent the artist ID. If I go into album now, notice that we have album ID and title, but we also have artist ID. And so if you imagine these 2 tables sharing this common column, what if we kind of stitch them together like this, lining up one on the left, the other on the right, thereby reconstructing all of the information and duplicating it as needed so that I get back just the album and the title and the artist? Well, how can I express that? Well, let me go ahead into CS50 IDE, where I have a copy of this file. Let me close all of my tabs from earlier and go into this file called lecture.db. And in lecture.db, in PHP LiteAdmin, we'll see all of those same tables, and I literally just imported it into SQLite. You'll see all these same tables. We can browse album just as before, and we just see a different format for the same data. It's the same data from the Google spreadsheet, which is just more user-friendly. And let me go ahead and do this. I could, of course, select star from album where artist ID equals 1 to get back all of AC/DC's albums. And indeed, here I have 2. They have, for those about to rock, We Salute You, and Let There Be Rock. They have 2. But notice, the rows I got back contain only what information? Album ID, title, and artist ID. I just know as a human that, oh, these are AC/DC's albums. But what if I want to know? Well, OK, I see that artist ID is 1. So all right, well, let me open like another tab here. And now let me select star from artist where artist ID equals 1. And so if I want to learn something about that artist, let me go ahead and zoom out, click go, and OK, now I get AC/DC. Well, this is great. Now I have 2 results, 2 sets of rows. This is stupid. Like now I'm just creating work for myself by having 2 return values. I could call db execute twice, but there's a better way. It turns out SQL allows you to join tables just using SQL itself. So I'm going to go ahead and do this. I'm going to go ahead and select star from album, but also from artist, where album.artistID, and let me scroll to the right, equals artist.artistID. So notice I'm saying select everything from 2 tables, but only do so where the album table's artist ID column has the same value as the artist table's artist ID column. That's kind of the stitching metaphorically of my fingers together, looking for that common column. If I go ahead and click go, wow, look at what I've just constructed. It's a lot of information, but I have album ID and title. I have artist ID still, but I have the name of that artist all together. So if you now let your mind wander back to the the Python code, oh, I could now get a whole bunch of rows containing everything I care about all at once. I don't need 2 select queries. I can join these tables in this way. And I use join very deliberately. It turns out that there's another way to express this same thing. Instead of using that comma syntax I did, you might see as well this: select star from artist join album on artist artist ID equals, let me scroll over, album dot artist ID. This is going to have the exact same effect, but you might just find that it reads a little more intuitively to you. Select everything from the result of joining these 2 tables. How do you want to join them? Well, join them on this equaling that. Just another way of expressing the same idea. And if I click go, I get back the same information. So ultimately, with joins, do we have the ability to reassemble data? So on the one hand, it's just good practice to normalize your database. Identify columns that have lots and lots and lots of redundancy and only store that information once. For instance, CS50 Finance, if you're supporting many different users, every time Malin or Brian or Veronica buys a stock, feels like it'd be a little silly to store Malin or Brian or Veronica along with Netflix, the symbol, and the number of shares one of us bought. Because Malin is going to appear all throughout the database. And what if I change my username or my name or someone gets married and therefore it changes? Like, why do you create that messiness for yourself? Instead, give Brian and Veronica and me and everyone else a unique ID. And when they buy something, just store their user ID or customer ID or however you want to think about it, just like with album ID and artist ID. And so normalizing a database is all about finding those commonalities and moving the data into its own table. And if you care about rejoining it, just use SQL to reconstruct that view of the data, so to speak. So what else can we do here as well? It turns out that there is in SQL not just primary keys, but there's unique constraints in some databases where you can specify, this isn't my primary key, but I want it to be unique. You can specify that something should be indexed. So it turns out that if you just know there's a field in your database that you want to be able to search on very efficiently, you can index it in advance. And you'll see or be able to do this if you like for final projects or even for the next problem set if you'd like. But what this enables are queries like this. If I want to go ahead and search for instance, let's say, what would be a good example? Rock. I'm interested in rock. So if I want to go into my SQL tab here, I could say something like this. Select star from album where name not equals, but where name is like, and then I'm going to say rock. But if I want any number of characters to come before that word, I can use a %sign. And if any number of characters after, I can use a %sign. These are like wildcards. In most languages, you would use star. In SQL, you use %signs. But it means the same thing. And if I go ahead and say go, now I get back. Oh, I got wrong. Lecture, album. Oh, title, I think is what I wanted. Let me try that again. Sorry. Where title, like rock. Let me go ahead and click go. And voila, here are all of the albums in the database that have the word rock in them. Now, as an aside, this table has a lot of more albums in it. And frankly, it's small enough, though. It has hundreds of rows, maybe a few thousand rows. None of us humans are really going to notice how slow linear search is. But if you start having thousands of rows, tens of thousands of rows, millions of rows, not having an index means that searching for something like rock is going to start at the top and search every darn field all the way to the bottom, big O of n. If you instead tell the database, I know I'm going to be searching on this column a lot, please index it for me, here comes the secret sauce. SQLite, Oracle, Microsoft's Access, and so forth. They will, using their own intellectual property, build up some fancy data structures, trees or hash tables or whatever, in memory, store the data for you in invisibly in that format, so that when you do ask for a question like, show me all the albums like rock, they can answer you in much faster time than linear. And that, too, is what you get with SQL that you don't get with CSVs. CSVs are, by nature, only linear. So we can do better, but you, the programmer, have to help the database and actually give it those hints, not just the types, but also hints like this. And as an aside, there's also the notion of foreign keys, where if you really want to lock things down, you can specify that if you ever see an album ID in another table, if it's a primary key in the album table, by definition, any other table, it's going to be called a foreign key, because it doesn't really belong there, but it's referencing a column elsewhere. So there's a lot more technology and vocabulary, and you're welcome to dive in deeper, and odds are many of you will for final projects by nature of wanting certain features, among them even the ones we've seen like auto-incrementing and not null. As an aside too, SQL even has functions, and for data scientists and statisticians, it's super useful to be able to just do math and summaries of data right within SQL without ever writing Python code or R or anything else. Built into SQLite and other databases are functions like this for average, counting things, getting the min, max, sum, and so forth. All of that you get for free with a lot of databases. All it takes in the context of Python is a line like this, but, there are some problems. And let's end by taking a look at two fundamental problems and threats that are too often underappreciated. And in fact, we have to fix a very serious vulnerability that I introduced into my very own code earlier. But first, the so-called race condition. In survey, let's see. Suppose that we think back at the very start of the semester, most of you signed up for a GitHub account for the very first time. And you went to github.com/signup. For those unfamiliar, GitHub is a website where you can save and store programming code that you've written and want to collaborate with others on. And you chose a username. And let me go ahead and try choosing a username like, say, J Harvard for John Harvard. Notice that the website immediately said the username is taken. All right, that's useful, and you can probably guess how this is done. Maybe a little JavaScript, using AJAX, talking to the server, getting the response, changing the HTML or the CSS or whatever. Might take some time to wire all that together, but that's probably what's going on. So let me try like a really long random username that is not taken. Hey, it's available, but probably is not a good thing that I'm streaming this on the internet, because if I wait long enough, I bet someone could, for playful reasons, just sign up for this, let alone anyone in this room. But you've just told me it's available. OK, so good. I'm really excited. I've got my username. Let me go ahead and type in my email address, mailin@harvard.edu, my password, 12345, take a few moments there, verify my account, and so forth. And I click Submit. Suppose that I'm told momentarily, sorry, that username's been taken. Could that happen? Yeah, I mean, if any of you were trying to mess with me, like right now, you would have signed up for that username and beaten me to the punch so that when I hit join, I get an error. That's the definition of a race condition, where two people or two users or two computers or two threads, if we really roll back to our discussion of threads in Scratch, are trying to do the same thing at roughly the same time. And if those two things, threads or humans, check the state of a variable, which is a fancy way of saying, is the username available, they both get back answers. But then some number of split seconds later, then they make a decision based on that information. There is a window of time, either split seconds or even seconds or minutes, where the state of that variable could, of course, change. So if you two literally right now on your laptop type that very long username, all of us would probably be told, like, green light, it's available. But only one of us is actually going to get it. And that's because of a race condition. Literally, all of us might be racing to sign up for that value. And it's when state can change in between things happening. This is a bad thing because it makes your data vulnerable to changes by someone you don't necessarily intend. Or if the database isn't smart, you might be able to do especially bad things. ATMs are a canonical example of this. If you had a malicious adversary trying to log into like 2 bank accounts at once or 2 physical machines at once, either with 2 cards or with 2 accounts and 2 laptops, you could imagine both of them trying to deduct like $100 from the same account instantly. Because imagine a poorly implemented bank website. It checks the account balance of the user logged in. Do you have $100? If the answer is yes, maybe both websites are going to say, yes, you may deduct $100. You hit enter, and voila, you deduct $100. The user gets it somehow because it's transferred to some other account. But the bank thinks it only did that once, deducts 100, but you've just walked away with 200 because you made a decision based on the same answer in 2 different threads or 2 different programs or 2 different computers. So long story short, this can happen even in the real world. An example I was taught by my advisor years ago was this. Suppose you and your roommates have a little dorm fridge, and you're in the habit, of course, of drinking a lot of milk. And so the fridge has run out of milk, and you come home, the first roommate after classes, and you realize, oh, I really need a drink of milk. And so you check the fridge, there's nothing there. So you close the fridge, and you walk into the square, go to CVS, and get in line to buy some milk. Meanwhile, your roommate comes home. Also, they really need a drink of milk, and so they check the state of the variable. No milk. close the fridge, and then walk to like Tommy's Convenience or some other place nearby and get in line for some milk. You, of course, then both get home eventually, and what happens now? Damn it, now you have twice as much milk, and milk goes bad quickly, so now this is a problem, a very bad problem. You have twice as much milk as you could possibly drink. But what's the origin of that problem fundamentally?
You're out of something.
You're out of something, but you need it, but why did I end up with 2? There's no flag, right? There's no indication. There's no sharing of state. You both inspected the value of the variable, made a decision independently on it, but the state of that variable changed on one of you, because when one of you came home, the later person, damn, like the milk has already been refilled. So how do you solve this in the real world? How could you avoid this problem? You could just, one, never do errands for your roommate. Yes, a shopping list, right? Gone for milk, Arrested Development. Always leave a note, right? You could convey that information. You could more dramatically lock the refrigerator, right? Padlock the thing. And so your roommate can't inspect the state of the refrigerator while you are gone, therefore not making us vulnerable to this. And I use the word lock deliberately because in databases, that's how they solve this. There is a feature in databases called locks, or fancier versions of this are called transactions, whereby you can guarantee something called atomicity. Where atomicity means you can do multiple things back to back to back without getting interrupted. So in the case of a bank, it is possible with SQL, using slightly fancier syntax that we won't dive into today, to solve this problem by saying, you know what, begin the following transaction. Check the state of the bank account, deduct this amount of money, and now commit the results. And while I'm doing that, lock everyone else out. Don't let any other customer or any other user do exactly that information that touches the same data until I am done. Long story short, you pay a price perhaps. You're literally preventing your roommate from accessing the fridge, and that's annoying, or you're preventing other customers from doing transactions. So hopefully the computer is fast at this, and you're fast at shopping, but you've at least ensured that you have atomicity. No operation can get inserted into your sequence of operations as by your roommate or some other computer or thread. So that's a problem with databases that we're only going to skirt over. And GitHub might solve this how? Well, by just not caring, potentially. I don't know what's going to happen if multiple of us try. I'm guessing they will just give n-1 of us an error message saying, sorry, that username is no longer available. Think about this. If you've ever bought airline tickets, this is a solved problem in that industry. It would be really annoying. If you just spent like an hour of stressful price hunting for a good airline ticket, you start checking out after adding it to your shopping cart, and 5 minutes later, after your name and email address and credit card number, the ticket's gone. So what do airlines do? They often give you like a 5-minute window, and some of the fancier websites show you the clock saying we guarantee this for the next 5 minutes. Hotels might do this too, where they lock the refrigerator for you by somehow altering the database to say, no one else can buy this ticket or this room for the next 5 minutes, much like the note or the padlock. So those kinds of things are all around us. But let's look one final example that's the worst threat of all is this. Previously, I allowed myself to search by name. So Q equals Brian, or Q equals David, or Veronica, or the like. And what did I do with that information? Well, if we go back into the IDE and actually look at that file in application.py, I simply formatted it using an F string inside of this SQL string. But what if my users were a little bit malicious? And suppose that someone doesn't want to just search for Brian, but you know what? Suppose they do something like, my query is delete from registrants where, sorry, Brian, name equals Brian, something like this. Now, this is not valid at the moment because this string, while I'm certainly allowed to type it in, is going to get plugged into my code, but in the wrong place logically. Like I'm going to look for someone's name called delete from registrants where name equals Brian, which is just nonsensical. It will return 0 results. But what if I do something like this, where I say Brian or delete from registrants, where I kind of finish the thought that the programmer had and then start my own new thought? Or another way of doing this is to use special syntax semicolon, something like this. Long story short, I could contrive a human malicious input that finishes the programmer's thought and returns 0 rows, but by the way, also sneaks one additional rogue query into the database. This is what's known as a SQL injection attack. And if you naively and very, very, very badly and incorrectly write code like I did, don't ever do this, you will be vulnerable to exactly this attack. Because You are blindly plugging in the user's input to a string that you are then passing to a database. This is a fundamental flaw in lots of applications, lots of languages where you have to distrust your users. It doesn't matter if it's for just students on campus or it's just for you and your friends. Never, ever, ever trust users' input, because either someone's going to mistype something and something's going to go awry, or you're going to have, like a bad apple, trying to hack into your website or your application by trying these kinds of commands. And you have to always write code defensively. So how to do this? There's a bunch of ways, but it turns out that what's dangerous about something like I just typed in is that it's the semicolon, for instance, and it's the quote marks over elsewhere. So the safest thing to do is, no matter what the user types in, escape things. You can use special syntax. We saw this in C. Generally, putting a backslash in front of something means don't let it have its default behavior. Instead, treat it specially. So you could use special code in Python that just says remove any bad characters or replace things. Frankly, you've probably been to a website where you've been told, sorry, you can't use that character in your password, or sorry, you can't use that in your username. That's just dumb. Like, that is the lazy approach to this. There is no reason to prevent users from typing any characters into their keyboard for their password, maybe even their username. That's kind of a lazy way of defending against this by saying, I don't trust any percent signs, any semicolons, any dashes, any apostrophes. Rather, just escape things. But it's silly for all of us in this room to write our own code for escaping users' input, or scrubbing it, as it's called, or sanitizing it, as it's called. Same things. Why don't we just use a library? Now, there's many libraries out there. The one that we're using at the moment is CS50, and the execute function does this for us. Instead of using f strings, which you should not use like this, you should instead do this. If you want to plug in a placeholder value to a SQL query, you literally use a standard convention that we have adopted too, where you just put in a variable's name but with a colon in front of it. And it can be anything. It can be Q, it can be X, it doesn't matter. But you want to just plug in some value there. So I'm going to call it name by convention. Then you close your quote and finish your thought. And then you go ahead and pass in the actual value, name equals Q. And now you have constructed dynamically a SQL string with a placeholder that is not Python's own curly brace placeholder. This is a special SQL convention where you say plug in value here. What value? We'll plug in this name's value, Q, whatever the human has typed in. And what our execute function will do for you is all of the fancy backslashing and all of the escaping, and will protect you from the user's data. And this is how truly simple it is. It doesn't have to be CS50's library. This is ever so common in all languages, but too few people know about it and use it. And so half the time you read about some database getting hacked or your data getting stolen, it is because of a stupid oversight like that. So just use libraries and escape users' input. We can see this now more concretely. All of the undergrads in the room have surely logged into either Yale's website or Harvard's website, which looks a little something like this here. You're prompted for your login name and your password or your Harvard key or the like. Well, how does this take effect in real terms? If I were to type in my email address, but then weird syntax like this, let's look at an example. Quote or quote unquote 1 equals quote 1. Notice it's not balanced. Like, it's kind of missing a quote over here, missing a quote over here, because the presumption is that maybe Harvard is vulnerable to this. I don't think they are. But suppose that the code running Harvard key in Harvard's login page looks a little something like this. This is bad. This is dangerous because they're just using f strings or format strings, which are just going to blindly plug anything in there. But if you instead and so if you let the human type in something cryptic like that, notice what has happened logically, where username equals me at example.emailprovider.com and password equals quote unquote, so nothing, or 1 equals 1. And why 1 equals 1? Well, notice if I go back, notice that there's a quote here and a quote here. And the reason that I didn't finish my second quote here or my second quote here is because I'm assuming, as a bad guy, like, I think Harvard is just going to blindly plug my input into a single quotes of their own. Therefore, I can finish their thought nonsensically. But notice logically what happens. Select all users from the database where the username is me at example.emailprovider.com and the password is nothing, or 1 equals 1. Well, when does 1 equal 1? Like, always. So this will always return users from the database and presumably, therefore, let me log in as one of those users. So incredibly simple to defend against this. Just use placeholder syntax and distrust and sanitize users' input. The syntax in SQL and the CS50 library is quite simply with that colon. but in other libraries it might be quite the same. So now you are all, families and students alike, inaugurated into the small class of folks in the world who understand particularly geeky humor. You might notice this meme that's gone around the internet for many years now, where someone either maliciously or humorously decided to paint this over their license plate. Let's enhance. Why would someone do this? Scanners, yeah, like toll booths are kind of going away, at least in the US, and they instead have like cameras or readers that are scanning the front of your car and trying to optically do OCR, optical character recognition, on your license plate. And the presumption here is maybe in some municipality there's some badly written code where they just blindly plug your license plate into their code, and hopefully you finish the thought where ZU0666, whatever that is part of the license plate, but semicolon, drop database table, ... And we didn't even look at that because drop is pretty extreme. It literally deletes a database itself. But this is a nice way of getting off the hook from a toll price. And most canonical, perhaps, XKCD is a very popular cartoon strip. It's particularly geek-oriented. And you'll perhaps understand this joke now as well among CS circles. You can kind of hear the laughter making its way through. So for here on out, if you take nothing else away, remember little Bobby tables with PSET are final. Will you actually implement CS50 Finance and coalesce all these ideas? Thank you so much to all of our families for joining, and we will see you next time.